Find the derivative of g of x equals the square root of the quantity 4x plus 1 over 4x minus 3. So g of x here is the square root of an entire expression, 4x plus 1 divided by 4x minus 3, which itself is a quotient. So therefore, we're going to be making use of the quotient rule at the very least. But before we do that, let's rewrite the root as a fractional exponent, first power, second root, or 1/2 power. Notice that we have that entire quantity to the 1/2. That means we're going to start with the power rule on that 1/2. And then we're going to do the derivative of the inside to complete the chain rule. Well, the inside of that power is a quotient, and there's where the quotient rule will happen in taking the chain rule of that power function. Gives you a hint of how to take the derivative here. So the derivative g prime of x will start with the power rule, bring the 1/2 down, leave the inside alone. We will subtract 1 from the power. I will call that 2/2. And now we multiply by the derivative of the inside, which is itself a quotient and therefore a quotient rule. Now here is the inside, and we're taking the derivative of that. Derivative of the numerator, a 4, times the denominator left alone, 4x minus 3, minus the numerator left alone, 4x plus 1, times the derivative of the denominator, which is a 4, divided by the denominator quantity squared. So there's the derivative of the inside, completing the chain rule. So now we have 1/2. We have a 4x plus 1 over a 4x minus 3 to the 1 minus 2, or negative 1/2. And we have this multiplying in here. Now what I'm going to do in here is distribute the 4 in all of this. So that'll be a 16x minus a 12. And I'm going to distribute the negative 4 into all of this, which will be a negative 16x and minus a 4. And all of this is over the denominator, 4x minus 3, quantity squared. The next step is to combine like terms in the numerator here, and the 16x and the negative 16x can cancel, and the negative 12 and the negative 4 will combine with each other. So g prime of x will equal, we have a 1/2. Now this quantity to the negative 1/2, what I'm going to do is separate them and have each of them raised to their own negative 1/2. We want to do that because we're going to be able to move them around or combine them. And I have in square brackets a negative 12 minus 4, that's a negative 16. And I have a 4x minus 3 squared. Now what I'm going to do is, instead of writing it as squared, I'm going to write it as 4/2. The reason I'm doing that is we're going to multiply these fractions, and this, when multiplied, will allow us to add the exponents because we have like bases there. If I multiply the numerators, I have a 1, I have a negative 16, and I have all of that. So when I multiply those, 1 times negative 16, I end up with negative 16. I have that 4x plus 1 to the negative 1/2. And then when I multiply the denominators, I have a 2, and I have a 4x minus 3 to the negative 1/2 and a 4x minus 3 to the 4/2. We will add the exponents. So 4x minus 3 to the negative 1 plus 4, 3/2 power. Now this 16 and this 2 can cancel down to leave us with an 8 there. So that will give us a negative 8, 4x plus 1 to the negative 1/2, and the entire thing over 4x minus 3 to the 3/2. The next step, I'm going to take that negative 1/2 power and move it to the denominator. So my g prime of x will be a negative 8 divided by, I have a 4x plus 1 to the 1/2 and a 4x minus 3 to the 3/2 power. One more thing we can do, that 1/2 power can be written as a square root. The 3/2 power, it's customary just to leave that as 3/2 power. We generally only write it as a root if it's a 1 over something, so it goes to a first power and some root. In this case, it's second root or square root to the first power. That's when we rewrite it using a radical symbol. The 3/2, it's usually left as the 3/2 power, though it does mean square root of the quantity cubed, and it can be written that way. So there's one optional way to write that. If we want to write that second expression in the denominator also within the root, that's possible. And here's an optional way to write the result. We can extend the square root over the entire thing by having the 4x plus 1, it's to the first power, and the 4x minus 3 to the 3 power. And there's an optional way to write that derivative g prime of x. Either one of those is valid.